Let's do problem 55 on page 196, and I'll read the problem. It says, on July 19th, 1969, Apollo 11's orbit around the moon was adjusted to an average orbit of 111 kilometers. The radius of the moon is 1,785 kilometers, and the mass of the moon is 7.3 times 10 to the 22 kilograms. How many minutes did the Apollo 11 take to orbit the moon once? And at what velocity did it orbit the moon? Okay, so here I've got it set up. Here's the moon. Wrote down the key values. This is 1,785 kilometers. You're going to have to change that to meters. Our height above the surface is 111 kilometers. And we want to know what's the period in minutes and the velocity in, well, it doesn't say, but we're going to do it in meters per second. I'm actually going to do part B first. And the orbital velocity equation is given to be this. Okay. Square root of gm over r. And we know what g is, we know what m is. We need to figure out what r is, and it has to be in meters. So r is equal to the radius of the moon plus our height above the moon's surface. And the radius of the moon is 1,785 kilometers, which is 1,785,000. Just add 3 zeros to make it meters. And then we're going to add to that 111 and then add 3 zeros to make it meters. That's our height. And so when I do that, I just add 1 to all these digits, right? So 1,896 meters. That's 1.896 times 10 to the 6 meters. And so now we can figure out what the orbital velocity is. This is 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared. And this is the mass of the moon is given to be 7.3 times 10 to the 22 kilograms. And you got to make sure when you type it into your calculator that you divide it by, you do this times this divided by this, and then take the square root of the whole thing. And when you type all that into the calculator, you should get an answer. And since I don't seem to have my calculator up here anymore,
Want a calculator?
I think it's that's nice of you. 1,600 meter. What did you get? 1,602 point. Yeah. Well, we don't know. So 1,600 is close enough. Meters per second. Now, how fast is that? Any of you run track? Do you know what the metric mile is? So the 1,600 meters. Anybody here run the 1,600 meters? That's a, yeah. Well, that was how fast they're running 1,600 meters per second. So that's how fast you're going. Basically, it's a mile per second. Now that's pretty fast. But if you're in orbit around the Earth, you're going 5 miles per second. So the moon has a much lower mass, so its gravity is not as strong. So you don't need to go as fast so that you're falling around the moon as you need to go to fall around the Earth. because this is how fast you need to go at this height above the surface to fall around the moon. You're falling continuously around the moon. Okay, well, now that we know that, let's do part A. And the way I like to do this, because it's just easier, is you say, well, the velocity is equal to 2 pi r over the period. Because 2 pi r, that's the circumference of a circle. And we're going around the moon in a great big circle. And the period is defined to be the time it takes to make one circle. So the period is equal to 2 pi r over the velocity. So that's 2 times pi, and then r we figured out to be 1.896 times 10 to the 6 meters. And we figured this out to be 1,600 meters per second. And when you do that, let's see, what time do we get? Then the book, they already converted it. Anybody anybody do it like this? Maybe I have my calculator here somewhere. Oh, I found it. Okay, let's do it. So this is when if you're watching online, this is great, because this is when you can skip ahead, right? So 2 times pi times 1.896 times 10 to the 6 divided by 1,600. And you get 7,445 seconds. But they wanted it in minutes. So put that over 1. And there are 60 seconds in 1 minute. Oh, sorry. 60 seconds in 1 minute, so the seconds will cancel. So you just take that and divide it by 60, and you get 124 minutes. Or you really should do 2 significant figures, but that's okay. 124 minutes, which is about 2 hours, a little over 2 hours. So it took them 2 hours to circle the moon back in 1969. For part A, you could have used, what is that equation? T squared equals, what is it, 4 pi over gm times the radius cubed. Is that the equation?
4 pi squared.
Huh?
4 pi squared.
Oh, pi squared, thank you. And this will work, and you'll get the same answer. In fact, this is derived by a substitution and so on, but to me, this is just a lot more work than doing it this way. So, if you know the orbital velocity equation, and you also know that the orbital velocity is also equal to 2 pi r over the period, you can pretty much solve anything you need using those 2 equations right there. Any questions on this problem? That is all.